Hey everyone, imagine you're watching an intense cricket match and the score is climbing, but you want to see how your favorite team is performing over time. That's where graphs come in. By plotting the runs scored per over on a graph, we can instantly see if the team's performance is picking up or going down. It's like having a pulse on the match without watching every ball. Today we'll explore how graphs are powerful tools to analyze and visualize all kinds of data, not only in sports but in science too. So let's dive in. But students, before we start, please don't forget to like, share and subscribe to our channel. That really keeps us going. Let's learn together.
Hello students. So before we begin in today's class, let's quickly recap what we had done in the previous class or the video. So if you remember, we had just introduced the new unit that is space, time and motion, and the first chapter that we are going to talk about is kinematics. So we have started with kinematics, which is basically the study of motion, and we had talked about how we will quantify motion. So we will start from there itself. The only thing that I want to remind you again, that we had a very brief introduction of distance and displacement. So today, before we begin to the next parameters, that is speed, velocity and acceleration, I think it would be a very wise decision to revise the concept of gradient first. So gradient is something that you should know, only then you will get a proper feel of what you mean by speed, velocity and acceleration. So today's class is going to start, we are going to start with discussion of what do you mean by gradient. So shall we start? You can just quickly write what we had done. So we were talking about quantifying motion, and then we can start with the concept of gradient. So first we are doing the math part of it. So we are wanting to understand how we are going to apply this in physics, but before that we should quickly revise what exactly gradient would mean. Okay, so the first thing that I would tell you, that if you have to imagine what gradient is, you just keep in mind it's just like slope. Slope tells you how steep anything is. So if it's more steep, it is like this. If it is less steep, it is like this. But then you would say, why do we use it here? So understand, we mostly discuss the behavior or the dependence of one physical quantity on another physical quantity. So let's say we have this x, we call this x as, let's say, independent variable. Let's call this x as independent variable. What do you mean by that? So we are changing x, and by changing x we are wanting to see the change in y. Now gradient is something related with graphs. I hope you know what significance graph has. Graph is a very easy and quick representation of any variation. So when we are drawing a graph, it is sometimes way better than tabulating everything and putting the corresponding values of y with respect to x. So y here means the parameter that we are going to see the change in. So can we call y as the dependent variable? Can we call y as the dependent variable? So now you should have an idea that x is independent variable, means we are changing x and correspondingly we are seeing the change in y. So x is our independent variable and y is our dependent variable. Right now we are mainly talking in context of graph. So how y is changing with x, and you should know that this can be mainly of two types. First, if we go on increasing x, then y also increases. In such a case, we will say that y is proportional to x. Y is proportional to x. Okay, somewhat what you see in this graph. On the contrary, if I have a graph like this, let's say if I draw this red line, pay attention. If I draw this red line, then what do you have to say? On increasing x, you see that y is decreasing. That is where you will call y is inversely proportional to x. You can think of n number of examples around you to understand how either one thing will increase with the other quantity or one thing will decrease with the other quantity. Though there is one more possibility. What if it does not change at all? It does not change at all. So for example, I can say, how would today's date change if I turn on the fan in my classroom or turn on the air conditioner? So the room will get cooler, but will it affect today's date? The answer is going to be no. So then we call y is an independent variable. It does not depend on x. It does not have any dependence on x. So three possibilities: y either increases with x, or it may decrease with x, or sometimes, very rarely, it might not even depend on x. In that case, you will see a flat line. In that case, you will see a flat line. So first, now you understand the meaning, because it's very important to understand the math behind physics. Only then you will have the conviction to move forward. So we call this as the y versus x graph. What do we call this? Y versus x graph. You can quickly draw this y versus x. This white line is showing that y is proportional to x, or y is increasing with x. Red line is showing y is decreasing with x, and the blue line is showing that y is not changing with x. You can make a note of it. Now, if I tell you that fine, y is changing with x, but how sensitively, how significantly, that is something that you will accommodate in the concept of gradient. So when I say, now let's first only consider the case where y is increasing with x. Now when I say, let's say that this is a situation where y is increasing with x, and then there is another situation, this, where y is increasing with x. What difference do you see? So in the first case, as x is increasing, y is increasing. In second case also, if x is increasing, y is increasing. But you will see that y is more rapidly increasing with x. Y is more rapidly increasing with x. So y is depending more on x. That is when you have a more steep graph. That is when you have a more, so the green graph is steeper than the white graph, means y is changing more rapidly with x. So gradient tells you that how rapidly y is going to change with x. Okay, you can take, again, you can take an example. Let's say if I say there is a point A, and if I say there is a point B. So let's say the corresponding value of x is x1 and y is y1 for A, and x is x2 and y is y2 for B. Then this thing, that is the change in x, the horizontal change, this we can call as run. What do we call this? Run. And this is therefore the rise. This is therefore the rise. So basically, what do you mean by gradient here? So you would say gradient, which we may also call as the slope, is nothing but the ratio of rise over run. Okay, that is change in y over change in x. Can you all see that? Y. So this is y2 minus y1, the difference in y's, and this is the difference in x. So can you also rewrite this as delta y by delta x? Yes, of course. So this is called the slope or the gradient. You might also relate this with the value as tan theta, since you do know now that tan theta is the ratio of opposite over adjacent or perpendicular over base. So you can call this as the tan theta. But one thing that was assumed here is that it's a straight line graph. That means y is directly proportional to x. It is continuously same variation. So if you are doubling the value of y, x is also doubling. That means it is a straight line graph. You don't have any abrupt change. Okay, that is also a possibility, that y might not change directly with x like this, and you can have a situation somewhat like this as well. But before we talk about that, you should make a note of this, that gradient tells you that how rapidly y is changing with x. Therefore, we can also call it rate of change of y with respect to x. You might be wondering, it's looking like a math class today, but this math class is going to be very important and crucial for you. Why? Because it's not only in context of this chapter. Gradient or rate of change of y with respect to x is something that we will almost use in every chapter of physics. So understanding this very properly really makes a lot of sense. So please keep that in mind, that gradient means the rate of change of y with respect to x. Please write this down. You can make one more note here, that if x increases, then y also increases. That means the gradient is going to be positive. Why do I say so? A positive change in x will cause a positive change in y. So both are positive, the ratio is positive. But if a positive change in x causes a negative change in y, do you remember the red line? The red line, increasing x decreases y. In that case, you will call the gradient as negative. In that case, you call the gradient as negative. You might not get a feel of it, that what exactly this would do in physics. So let me tell you one thing. Most of the time, the x here, especially in context of this chapter, is going to be time. Is going to be time. So we will see things, how they are changing with time. So on the x-axis, mostly it is time. So this will basically tell you how anything changes with time. Okay, so that is one thing that you can keep in mind. You can make a note of all this, and then we will move on to the next part. You can make a note of this. You can pause the video. You can pause the video and then copy it down. Okay, so gradient, tell yourself, explain yourself, gradient is telling you how y is changing with x. Okay, so now I'm moving forward and talking about a general situation where y is changing with x somewhat like this. I'm removing this. Now when y is changing with x somewhat like this, you would say that, let's say this is again a point x, the corresponding value is y, let's call this point as a, and then there is another point b, the corresponding value is x2 and the corresponding value is y2. So this is x1, y1, x2, y2. Imagine if I now want to see how y is changing with x. So it is changing some non-linear pattern. It is changing in some non-linear pattern. So we are going to see the average effect of it. So when we draw such a line, okay, that starts from A and let's say proceeds till B, then we can call this as a secant to the curve that cuts the curve in 2 points. So what are we studying here? Again, we are studying the gradient, that how y has changed on an average with x, how y has changed with x. Okay, so let's say this is the change in x, that is delta x, and this is the change in y, that is delta y. Then this is going to tell you tan theta of the secant. This is going to tell you tan theta of the secant. So from A to B, you will get an idea of how y has changed with x, but it is not a clear-cut idea because y is changing very abruptly with x. So there's no linear relationship. So what we are studying is the average change. We are studying is the average change. Just keep listening to all this. All this will not make sense right away. But when we will talk about average velocities, instantaneous velocities, all these things will make complete sense to you. So have a little patience here and just keep listening to what I am telling you. Okay, so again, so now tan theta is going to be delta y by delta x, and that will tell you how x has changed y in this whole region on an average. So you can call it as the average change or average rate of change of y with respect to x in the interval from a to b. So maybe going forward it might change in some other fashion, but it is only from between a to b. So draw this diagram, and then we will talk about how we are going to discuss the instantaneous effect through this graph. But before that, this is the average effect. This is the average effect. You can write this as average change in y with respect to x. Please make a note of it. So now you can imagine this is delta x, this is delta y, and this is how you're observing how y is changing with x. Okay, now what if I tell you I have to see a very instantaneous change, a very small change? So you would say in that case a and b, the points we were discussing, will be very close to each other, They should be that close that a is this point and b is this point, that this change you cannot even visualize. Okay, this change is very small. So when you are doing this, listen to me very carefully, when you are doing this, so observation point becomes very close to each other. Observation points become very close to each other. That is how you talk about instantaneous change. So instantaneous change would mean that at a particular instant or at a particular point, so basically a and b are that close that they are almost merging into each other, and in that case you will say delta x is very small or the change in x is very small. In that case only the difference is that instead, listen to me very carefully, instead of a secant, this line will start looking like a tangent. This line will start looking like a tangent. So if I may draw this, it's going to be somewhat like this. So now this is a tangent. In that case you would write that tan theta is equals to delta y by delta x, but delta x is very small, so observation points are very close to each other. Imagine if I bring a secant. So let me do it for you. So let's say this was a secant. Understand, this was a secant, right? Now if I choose this secant and I start moving it towards the end, are you listening to me? So this is secant, right? And if I start moving it towards the end, then this becomes the tangent. So secant would become just like tangent, right? But when the observation points will come very close, so you are talking about that particular instant. So keep that in mind, that if delta y by delta x, if we say that, let's say tan theta is equals to delta y by delta x, limit delta x tending to 0, then this becomes the slope of tangent, and more its value, that means a steeper graph. Less its value, so it's a less steep graph. More steep graph would always mean higher dependence. Lesser steep graph will mean lower dependence. So now we are discussing the rate of change of y with respect to x at a particular point or at a particular instant. So in that case, listen to me very carefully, though if you have math, you will know that ultimately this can be written as dy by dx. So when we use the word d instead of this del, then we are precisely wanting to say that dy means a very small change in y, and dx, so dx is a very small change in x, and dy is the corresponding change in y. So what is the difference between delta and d? Delta means the average change, where you are seeing the average effect between 2 points. But if you are saying dy by dx, then you're talking about the instantaneous change. That was the slope of secant. This is the slope of tangent. Okay, so keep this in mind. This will be very useful. I will let you know how in the coming classes, but for now you make a note of this, that was the secant. Now you draw the diagram again with the case of tangent. Okay, and do show this as well. Do show this, that this is theta, that is the slope of tangent. So now after this we will talk about the other parameters. So we had discussed distance and displacement, but for understanding speed, velocity and acceleration, you should have a sense of gradient. So I hope I've given you a decent idea, maybe not very detailed idea, but this will help you in understanding speed, velocity and acceleration very much in detail. So now after this we will start discussing about speed, velocity and acceleration. So now let's start discussing about the two parameters, that is speed and velocity. All right. So first let's talk about speed. You have a decent idea of what speed is. You would say it tells you how fast any object or any body is moving. Absolutely right. Speed tells you how fast a body is moving, means what? How rapidly it is covering distance. So more speed means the body is covering distance rapidly, that is in lesser time, while less speed would mean that the body is taking time to cover that particular distance. So can we simply say that speed is the rate of change of distance with respect to time, or simply distance traveled per unit time? Okay, so that is the basic definition of speed. Speed of any object indicates the distance traveled per unit time. Distance upon time is speed. That is why distance has a unit meter and time has a unit seconds. So speed will have a unit of meter per second. This is the standard international unit. Though there is one more common unit which you can obviously relate with. What if the distance is indicated in kilometers and time is indicated in hour? Then the unit would be kilometer per hour. So these two units you need to toggle between. So you should have knowledge of both the units, kilometer per hour and meter per second. So for example, if you want to convert kilometer per hour to meter per second, because precisely they might ask you the answer in meter per second. So I think this conversion is very simple for you, since we know that 1 kilometer is 1000 meter and 1 hour is 3600 seconds. So this is the factor that you need to take care of whenever you want to convert kilometer per hour to meter per second. So this factor is basically 5 by 18 when you cancel the common factors. So 1 kilometer per hour is equivalent to 5 by 18 meter per second. Just keep that in mind. So again, what is speed? You would say speed tells you how rapidly any object is covering distance. There's no problem with that. But there is a problem with something else. What is that thing? The thing is that speed of an object cannot be constant throughout. Like it is a very, very rare scenario where you would say that, you know, an object is covering distance at the same speed all the time. Imagine you are traveling in a car on a busy road. Your speed, your rate at which you're covering distance cannot be constant. Depending on the traffic condition, your speed might also go up and down. So this is the case where you call the motion to be non-uniform. So depending on speed, we can classify motion in two parts. First is uniform motion and second is non-uniform motion. Okay, so uniform and non-uniform. Now do you understand? If something is traveling with a constant speed, imagine a plane cruising. So if it's cruising, there's no hindrance, there's no turbulence. Let's imagine it's a clear sky, then it might just cruise at a constant speed. In that case, you will refer the motion to be uniform. So speed is distance per unit time, The SI unit is meter per second, but the problem is that speed does not remain constant most of the time. So your value of speed is changing. So that value that you have at a particular point is called the instantaneous speed, So there are two types of speed. First is instantaneous speed, that is your speed at a particular instant, what your speedometer would be showing. But since we have to sometimes summarize the whole thing, so for example, if I tell you that you have traveled from city A to city B and it is like 300 kilometers and you took 5 hours, and you have to summarize what was your average speed, you have to summarize it with single value of speed, that is your average speed, then you would say distance is, let's say, 300 kilometer, distance is, let's say, 300 kilometer, and time is, let's say, 5 hours, then your average speed is going to be the total distance, that is 300 divided by time, that is 5. So it is going to be 60 kilometers per hour. That is going to be 60 kilometers per hour. So that is your average speed. So where do you make use of average speed? When you are wanting to summarize the whole journey. When you are wanting to summarize the whole journey with a single value of speed. That is when you make use of average speed. So I hope it is very clear. All these things, you may write this down, but what is speed? It is the distance traveled per unit time. Speed if an object is constant, then the motion is said to be uniform. Next, it is a scalar quantity with SI unit meter per second. So while specifying the speed, we are not interested in giving up the direction. So direction is something which we will take care in velocity. So first, if you want to write all this, you may write, but I want to summarize this by taking a very quick example as well. What is this example? So a man travels from A to B, okay, in time 20 seconds. A man travels from A to B in time 20 seconds, and then from B to C in time 10 seconds, and we have to find the average speed. So this can also be a situation where for a part of the journey it is traveling with some other speed, for the other part of the journey it's traveling with some other speed, and you want to summarize the whole journey with a single value of speed, that is your average speed. So can we do this? You give it a try. I will wait. You can pause the video. I can erase this first, then you can give it a try. So now let's do it. First, let's talk about the total distance. Since it is from A to C and it's moving on a straight line path for now, so the total distance is going to be 500 meter plus 100 meter, that is 600 meter. While the total time of the journey from A to C is, so the first part is 20 seconds, the second part is 10 seconds, so the total time is 30 seconds. So we have the total distance, we have the total time, and for the average speed, mind you, it is the average speed from A to C, so it is going to be 600 over 30, that is going to be 20 meter per second, that is going to be 20 meter per second. So average speed is the total distance divided by the total time. So I've plugged in the value of total distance and the total time. So what is the formula for average speed? Total distance divided by the total time. Okay, I am just giving you an idea of speed and velocity in this particular class that you might also be knowing because of your previous classes, but we have to discuss the fundamental things before we move on to the complex things. So we cannot straight away jump to that level. We still would like to discuss the fundamentals of these basic quantities. Alright, you can copy this down, pause the video and copy this down. Then we will move on to the next slide. Okay, so the next thing that we wish to talk about is velocity. So I'll keep it very crisp and simple in this class. Velocity is the same thing as speed, just that there are two differences. Velocity will do the same task for displacement as speed is doing for distance. So if I said speed is the rate of change of distance, then velocity will be the rate of change of displacement. How rapidly an object is being displaced, is changing position. So not only that, one more thing, velocity takes into account direction. So you can say that speed with direction will give you the velocity. Speed plus direction will give you the velocity, since it is a vector quantity. Okay, so what is velocity? Velocity is the rate of change of displacement. It also describes the direction of motion. There is no doubt about it. Whatever is the direction of velocity is actually the direction in which an object is moving. Okay, mathematically it is the displacement per unit time. So again, it's a very similar thing. It is a vector quantity with SI unit meter per second. You know, sometimes I can give you an example. Sometimes they might differ very much from each other. So for example, when you say average velocity, so you would say it is going to be the displacement over time. It is going to be the displacement over time, or displacement divided by time. Now let me give you an example of an electron which is orbiting around a nucleus. Let's say around a nucleus. Can you even imagine that electron speed is going to be way too much? When it is moving in an orbit, its speed is going to be way too much. But if you know a little bit of structure of atom, you would know that this orbit is very small. This orbit is very small, of the order of angstrom, even less than a nanometer. So can you say the electron is only moving in that area? So its position is not changing much. So we can say the velocity is not much because its position is not changing, but its speed is still very high. Why? Because it is covering distance, but effectively it is not being displaced. It is somehow confined within that region. So that can give you an idea of how speed and velocity differ from each other, because velocity is related with displacement while speed is related with distance. Okay, so this was just one example, but yeah, instantaneously at a given point in time, you can say that velocity and speed are the same, just that you have to include the direction in velocity. Okay, next thing, that if we have to finally end today's class, we can say that if average velocity we just defined was, let's say, change in displacement over change in time. So if I write change by delta, so just now we have learned today that if I have to define, let's say, instantaneous velocity, if I have to define instantaneous velocity, just an introduction of it, then can I say that an instant would mean a very small time interval? So can I say that limit delta t tending to 0, delta s by delta t, which is nothing but ds by dt. So if average velocity is delta s by delta t, then instantaneous velocity is going to be ds by dt. So this is the slope of the secant of the graph. This is the slope of the tangent. So the gradient or the slope of the tangent is going to give you the instantaneous velocity. Don't worry, we'll do the questions, we'll do the graphs in detail, but just for an idea that because we have talked about it in gradient thing, so we have to discuss that how average velocity is determined. It is delta s by delta t, while instantaneous velocity is ds by dt. Okay, one last example I would like to take before we finish this topic is basically to differentiate between speed and velocity again. Okay, so you may write this down and then I will take that example. Okay, so what is this example? A person is traveling from A to B, then it travels from B to C, and then it returns back to B. Okay, finally he returns back to B. Okay, all this is fine. So if we have to talk about, first he started from A, he went up to C, let's say he went up to C, and after C he came back to B. So we have to find the average speed and average velocity. So you might have done such questions in your previous grade, I do agree, but it is again to give you that revision of topics, that how they are different from each other, how average speed and average velocity would differ, and what better way than taking a very simple example. All right, so average speed first. So you would say it is the total distance divided by the total time. So what is the total distance? Total distance is going to be 500 plus 100 and then plus 100 again. Why? Because he went A to B, then B to C, and then C to B again. So total distance is the total length of path divided by the time. So what is the time? A to B he travels in 20 seconds, then it goes from B to C in 10 seconds. So 20 plus 10, and then further it takes 10 seconds to come back to B. So 10. So it is going to be 700 divided by 40. 700 divided by 40, that is 350 divided by 20. Okay, so that is going to be 17.5 meter per second. That is going to be 17.5 meter per second. On the contrary, his average velocity is going to be the displacement. We can say the net displacement divided by the total time. So what is the net displacement? So imagine if he went till C and then came back to B, we are not bothered what happened in between. Initially he was at A, then he is at B. So the displacement is only 500 meter, and you can add the direction also towards right, and the time is 20 seconds. So average velocity is going to be, so 500 divided by 40, sorry, 500 divided by 40. So the total time is 40. Okay, 500 divided by 40, that is 12.5 meter per second. So average speed is 17.5 meter per second, while average velocity is 12.5 meter per second. So you can clearly see that speed and velocity are different, because in speed you worry about the distance, while in velocity you worry about the displacement only. So it's the change in position, which is 500. So I've given you a quick recap of things. In the upcoming classes we will talk about these quantities again with a new perspective, which you, I think, would be able to understand if you have seen this video. So do watch them before you go on to the next classes. But that's all for this class. Thank you.
Enjoyed this video? Please don't forget to like, share and subscribe to our channel.